So the first thing we're going to do is find the amplitude. And the thing that's sticking out at me is that it's no longer, the axis of wave equation is no longer at y equals 0. It's going to be y equals 1, 2, 3. So I know it's been shifted up. So how far, so to find the amplitude, how far up and how far down that is, does it go? And it's going to be 1. So our A is going to be equal to 1. Okay, so the next thing we're going to find is the period. So what is, how long does it take to go from here all the way to here? So instead of, using pi's like we're used to, these are just regular numbers. So the time period that it takes to get from point A to point B in this case is 8 instead of like 2 pi. So that's going to be very different. So let's go ahead and find B from that. So 2 pi over B equals 8. So B equals 2 pi over 8 or pi over 4. So that's what we're going to use there. We've also talked about the axis of wave equation. It's also called the midline. Like I said, I call it axis of symmetry. But really what you're doing is you're cutting that, that function in half. And that's going to tell us, that's going to give us our k, how far up or down we go. So now we are going to think about, okay, well, if it were a cosine equation, what would it look like? And if it were a sine equation, what would it look like? And the thing is, so let's start with the sine. So select a point on the curve where the curve intersects the axis of wave. So what's nice about this one is it starts right here. So that's why I'm starting with the sine function. And it says determine the translation amount hk from point 0, 0 to this point. So sine for this one is pretty straightforward. Okay, so since it crosses it right here, so we don't have to look at it really shifting at all to the left or right. So that would be where that h is. Our h is going to be 0, and our k is going to be that 3. Now the k is going to be the 3 in both sine and cosine. That's not going to be any different. So let's go down here. So this is going to be the equation of my graph. Now, go ahead and kind of reread this and go back up here. And I could say, if I were forcing a shift, if I said I can't use h as 0, I could also use h at 4 because that's where it intersects that axis of the wave. So I could also say sine of pi, or sine pi over 4, and then x, remember it's always opposite, minus 4 plus 3. So this would be another example of an equation. We could just keep going on and on and on forever. Okay, now let's kind of transition on to cosine. So some things are going to be the same. This B is going to be the same, and K is going to be the same. And also our amplitude will be the same. So let's go up here, and it says determine the translation amount when moving from 0a to the highest point on the curve. So that's where we're going to start. So let's get a different color. We're going to start right there. So I just want to point out that cosine curve, it kind of is going to go off the graph, but it's going to do that. And notice that it would go from 2 to 10. And so that's why our period is not affected at all. The only thing that is affected is notice how it's shifted to the right 2. So that h is 2, so I'm going to say x minus 2 down here. So my cosine graph is going to be y cosine pi over 4 x minus 2, and it's still shifted up. That's still equilibrium position is still at 3, y equals 3. And so we're just going to say plus 3. I want you to go through the same process with this. So this is the first thing that I noticed is I think this would be easier starting out with the cosine because I see that look first. But I didn't see the amplitude as clearly as I did before. So I went ahead and went through the formula, and I saw that the amplitude was 5/2. So from bottom to top, that's 2.5. So I'm going to cut that in half. So let's go up 1/2, 1, 1.5, 2, 2.5. So right here, this is going to be our axis of wave equation at y equals 3/2. Okay, so the period, let's see, it starts here and it ends here. And so that look is pi. So since our period is pi, then I'm going to put it in the formula, 2 pi over b equals pi. And so our b is equal to 2. Okay, so since I saw this as a negative cosine graph, I have to incorporate that on the equation that I choose to use. But what if I looked at this as a positive cosine graph? So let's say I went from here all the way up to here. So my period's going to be the same, my k is going to be the same. I'm going to have a lot of the same things, except it's going to be shifted. So my h is going to be different. It's going to be shifted pi over 2 to the right. So if I wanted to make this a positive, I would say this. Now, both of these are correct. There's nothing wrong with either of these. Let's go ahead and go on to sine and see what we can come up with there. So notice how many things are similar between sine and cosine. So this may or may not be positive. I don't know. I haven't even looked at it yet. But really, we're focusing on if this is positive and negative and what is included with the x as my h. So let's go back up here and see. So the rule is where it hits that axis of wave equation or equilibrium position. So we're going to start here and go to here. So notice it was shifted pi over 4 to the right. And notice that it is positive, 0, and like the basic one would be 0, 1, 0, -1, 0. So it's a positive. So minus pi over 4 is all I have to do. Okay, go through the same process with this one, see how you do. Okay, so for this one's going to be a little tricky. So first of all, I started with the amplitude, and so I wanted to find the axis of wave equation. So the highest it went is 2, the lowest is -1, and so I figured out that my amplitude was 3/2. So my axis of wave equation is going to be right here at y equals 1/2. So don't forget that this is going to be my k, so it's shifted up. The next thing I have to find, which I think is kind of tricky in this one, is the period. So look and see if you can find a complete cycle. So when I do that, I see that it's starting here, going up, and going back down here. So I'm seeing a negative cosine graph. So where does it begin? Where does it end? So what is that period? So it begins at -3, it ends at 7, so that period is going to be 10. So now I have to find the b value. So 2 pi over b equals 10, so b equals pi over 5. Okay, so we have our 3 main things that we need. So I'm going to start with the cosine. I see that negative cosine going on there. So I'm going to say -3 cosine of b, which is pi over 5, and then x minus something or plus something, and then plus 3/2. So let's go back up here and see where it was shifted. So it was shifted to -3, so I'm going to say +3. If I wanted a regular, like positive 3/2 cosine, let's look at that. So let's go back up here. I'm going to take this off. Okay, so I go from here, and then I'm running out, but it would eventually go back up here again. So that would be 2. So it would be shifted to the right 2. So it'd be x minus 2. So both of those are totally okay. There's actually like an infinite amount of equations that you could write for this. So go ahead and try sine. And guys, I just realized that this is not 3/2. It was our last one. This is 1/2 and 1/2. Sorry about that. Okay, so this looks like the best I can do. Actually, I'm going to shift it back to here. So I'm going up, then down, and then it would continue going up again. So this is going to be a positive A. So let's go down here. So I have 3/2 sine of pi over 5 x something plus 1/2. So let's go over here, and this is going to be negative 1/2. So I'm going to say plus 1/2 here. If you did use this original one, so this one right there, then that would make it a negative A because it's going down first. And so let's just talk about that. That'd be negative 3/2 sine of pi over 5. And then x, what is it, minus 4.5? Plus 1/2. So either one of these, again, would work. And that is it.